Hey everyone, welcome to Insights by Arish. In today's video, I'm going to explain you about hyperparameter tuning in machine learning. Now, you all might have heard about this term hyperparameter. This is a very important term from the perspective of machine learning, as hyperparameter means a parameter whose value affects the accuracy of our model. The parameters, when we change their values, the accuracy is also gets changed. Either it increases or it decreases, but it gets changed. The parameters whose values affect our model's accuracy are called as hyperparameters, and it's very important to tune your hyperparameters. You need some technique in order to gain the appropriate parameters for your model. When you randomly train your model onto some particular algorithm, in that case you are getting a generalized accuracy, but if you want to increase that accuracy to its best limit, then you need to use the hyperparameter tuning method. And for this hyperparameter tuning process, we use the technique called as GridSearchCV. Here we feed all the hyperparameter values that we want to check upon, and then it stores all that values into some variable. Then we create a data frame out of that variable, and then we plot that data frame. Then we try to visualize that data frame, and we then understand what values of our hyperparameters are the best. Here I am going to demonstrate an example of random forest classifier, that how after hyper tuning your values of hyperparameters, the model's accuracy changes. So we'll start by importing the necessary dependencies that we require. So first we require pandas, and then we also require cbun, because we are going to import the dataset from the cbun itself. Let's run this. And if you want to check what all datasets are present in the cbun library, you can just do sns.getDatasetNames, and let's run this. These are all the built-in datasets present in the cbun library, and out of this I am going to make the use of titanic dataset. So let us load that. We'll say df is equal to sns.load dataset, and just provide the name of dataset. So let's run this, and let us check the dimension of our dataset. Also, let us try to visualize it. So this is our titanic dataset, and I'm going to just demonstrate a very basic example, because the motto of this video is not to show you about data cleaning and data transformation, but it's about how to perform the hyperparameter tuning here. So we'll just do data cleaning in short. So we'll start by just removing the unwanted columns that we don't require. We'll say drop columns is equal to, so I will just provide all the columns that I don't require here, which is SIBSP, then patch, then embarked, then class, who, adult male, deck, embarked town, and alive. These are all the columns that we don't require, so we are just going to drop them, and I will say in place is equal to true in order to make the changes permanent. So let's run this, and let us try to display it. So this is our dataset right now, and survived is our target feature. This is what we want to predict, and all these are our input features. Now we just have two categorical values here, sex, that is your gender, and alone, that whether the person was alone or not. So we'll just randomly use the replace method to convert those categorical values into the numeric ones. So I will just say, I will check the unique values from the sex column here. We just have two values, and I will again check the unique values from alone column. So we just have two categorical values in both the columns, and hence we are going to make the use of replace method. So I will say df.sex.replace is equal to, here I'm going to provide the values that I want to replace. So I will replace the value male with a 0 and the value female with 1, and I'm just going to say in place is equal to true, and we are going to repeat the same thing for the alone column as well. And here we'll say false is 0 and true is 1. Let's run this, and let us try to display our dataset again. So now we have converted our categorical values into the numeric ones, and we'll just check for null values here. So we'll say df.isInA.sum. So we have 177 null values in our age column. Now there are two techniques to handle that. Either you can replace it with 0, or either you can replace it with the mean of your age column. So we are going to use the second technique here, that is replacing the values with the mean of the column. So I'll just say df age is equal to df age dot fill any method. I'm going to make the use of fill any method to fill the missing values, and here I will say mean of age column. Let's run this and let us again try to check. Let us confirm that we don't have any more null values here. So we have performed all the data cleaning part here. The next thing that we want to do, we want to perform data transformation, which is an important step here. Basically it means we want to convert all the data, or we want to bring all the data on a one single common scale, that is between 0 to 1, and hence I'm going to use min-max scaler here. So for that, first we need to divide our data set into the input features and the target feature. So X is a data frame which will consist of all input features, and from this particular data set we want all the features to be included in our input data frame except for the survived column, which is our target feature. So I will just say df.drop columns is equal to survived. That is, I'm going to involve all the columns from the data frame here except for the survived column, and here in my target feature I will say df survived. Let's run this and let us just confirm. Fine. Now the next thing that we are going to do is to perform min-max scaling upon this data frame, and for that we require the min-max scaler first. So here I will say in import dependencies from sklearn dot preprocessing, I'm going to import min-max scaler. Let's run that, and here I will say scaler is equal to min-max scaler. Now this scaler is an object of min-max scaler module. So I will say min-max scaler here, and I will store the transformed values in the X data frame itself. So I will just say scaler dot fit transform. You can do that in two single separate ways, either first the fit method and then the transform, but I'm going to do it in a one single go. So we'll say transform the X data frame. Let's run that and let us try to visualize the transformed values here. This is our data frame right now, which that we have transformed the values from the data frame between the values 0 to 1, and we have normalized our data. Now here we will perform train test split. So we'll say xtrain comma, so we'll say xtrain comma xtest, then we have ytrain and ytest, and here we require a module train test split, which I'm going to import it here. So I will say from sklearn dot dot model selection, I'm going to import train test split. Let's run that and we'll just say here train test split. Here I'm going to provide my input data frame and my target feature, which is X and Y, and then test size is equal to 0.2 and random state is equal to 42. Let's run that and let us check the shape of our xtrain and also xtest. So we have 712 rows in our training set and 179 rows in our testing set. Now here we are going to build our model and check its accuracy before GridSearchCV, that is before performing the GridSearchCV. That is, we are going to evaluate our model before tuning their hyperparameter. So here we are going to just simply import the algorithm and try evaluating our model with the help of default parameters. So here we are just trying to evaluate our model with the default parameters of the algorithm. Now we are going to use the random forest classifier here. So I will just say from sklearn dot ensemble, I'm going to import random forest classifier. Let's run that and here we'll build a model. We'll say model is equal to random forest classifier. Here I will say njobs is equal to 1, which basically means you want to do parallel processing, and I will say random state is equal to true, which means you want same instances to be included every time you rerun the code. Let's run that and we will also need to say model.fit So I will fit my training sets here, xtrain and ytrain. Let's run that. And after that, let us predict the accuracy here. So we'll say model.score. I will evaluate my model on the testing set. So x test and y test. And we'll multiply it by 100 to visualize our accuracy in percentage format. So here we are getting an accuracy of 79%. We haven't hyper-tuned our parameters. We went ahead with the default parameter values here. Let us check what accuracy we get after hyperparameter tuning. So to perform hyperparameter tuning, you require GridSearchCV module. So we'll just say from sklearn dot model selection, I'm going to import GridSearchCV. Let's run this. And here we will build a classifier. So we'll say classifier is equal to, I will say GridSearchCV, the algorithm onto which you are working. So I will say random forest classifier and just provide some basic default arguments here, which is njobs is equal to 1 and random state is equal to true. And then here you will start actually giving the parametric values that you want to evaluate your model upon. Now if you want to check what all default parameters or what hyperparameters your random forest classifier consists of, you just need to do something like this. You just say question mark and random forest classifier here. Let's run that and you will get this. Basically this consists of all the hyperparameters of your random forest classifier. These are all the hyperparameters, and we aren't going to evaluate our model upon everything but just upon the important parameters here. Now these are the default value of your hyperparameters. Whatever they have mentioned it here, they are your default values, and we are just going to try it on the new values. So the first hyperparameter that we require here is n estimator. N estimator basically means the number of decision trees in your random forest classifier. So I will say n estimators. The default n estimator value is 100, which means you have 100 decision trees in your random forest classifier. And I am going to say I want to evaluate upon 100, 150 and 200 estimators. The second hyperparameter that we have is the criterion. On what criteria you want to split upon your tree. Like if you take an example here, like you can divide your tree on to various bases like Gini impurity, entropy, log loss. So upon what basis you want to divide your tree into two halves. So that's your criterion, and the default criterion is Gini. Your decision tree basically splits your root node on the basis of Gini impurity value. I will say criterion, and the values of criterion, if you want to check, are mentioned here. So these are the three values. Let us say. Now the next hyperparameter that you want is max depth. That is the max depth of your trees in the random forest classifier. So the default value of max depth I think isn't given here, which is none. So it depends upon your data set that how many max depth your model will have or your random forest will have. So here we'll just say we want 5, 7, 10 and 12. The next hyperparameter that we want to evaluate our model upon is a mean sample split. That is, by default, your random forest classifier splits your node into two children nodes. But if you want to change that, if you want to split your node into more than two children nodes, then you can specify that value here. You can just say mean sample split. First, I'm going to supply the default value, which is 2, then 3, then 4. The next hyperparameter here I'm going to try is max features. That how many max features you want to include. Max features, by that what we mean is as you know, you have multiple decision trees in your random forest classifier. Like for example, we are evaluating our model upon 100, 150 and 200 decision trees. So initially you have 5 columns, or you can say 5 features in your data frame, in your input data frame. And when you are evaluating your multiple decision trees, you want all the features to be included into that model, or you just want to some specific features to get included into your model. That depends upon you. So what are the maximum features you want into your single decision tree present in the random forest classifier? That value you want to supply it here. the default max features value is a square root, which means it takes the root of original number of data features present in your data set. For example, if in your data set it consists of 5 features, then it will take the root of 5, it will round it up and will split your and will consider that many number of columns into every decision tree. So here I will say the max feature that I want are, firstly, I want a decision tree only to be evaluated upon 2 features, then upon 3, then 4, and then 5. That is all the features. So this many hyperparameters you have in your random forest classifier, but I'm just going to evaluate my model upon some important ones. After building up this classifier, you are going to fit it. So let me just remove this, and here we'll say classifier dot fit. I'm going to fit it on my X training and Y train set. And let's run that. It will take some time. Now after that it's done, the next thing that you want to do is you are going to store the results that you got from this classifier into a data frame. So let us create a data frame here. We'll say classifier data frame, and we'll say pd.data frame. And here we are going to save the result. Then we are going to say classifier dot cv underscore results underscore, and let's run that. Now we will try to display the columns classifier df has. So we'll say classifier df dot columns. Let's run that. So these are all the columns present in the classifier data frame, but we don't want to check all the columns here. We just want to check the important columns of parameters that we have provided and the eventually the score accuracy that we got. So we will just say classifier df, and here we'll try to display only the columns that we require. The first criteria, first hyperparameter we had here was n estimators. So we want to check the parameter criterion, parameter max depth, max features, min sample split, and n estimators. Only 5 hyperparameters we provided there. So we'll just check for this 5. And then you also want to check the mean test score here. Now you also want the highest accuracy, the parameters that gives you the highest accuracy to be displayed on the top, and hence we'll sort it by the mean test score, and we'll set ascending is equal to false, which means it will display us in descending order. We'll say sort values, and here we will say by, like by what parameter you want to sort. So I will say I want to sort it by mean test score. And then I will set ascending is equal to false, and I only want to check the first 5 rows. So let's run that. Now as you can see, the highest accuracy, initially we had an accuracy of 79% when we just tried to evaluate our model with the default parameters we had. Now these are the parameters that we are getting in our first row, that is the criterion should be Gini, max depth should be 7, max features should be 4, and min sample split should be 3. Now what were the default parameters here? If you try to check again the random forest classifier here, let me run. So the default criterion was Gini, that's fine. The max depth here was none, because it was eventually going to get decided depending upon your data set. The min sample split, here the min sample split was 2, but our model is saying that the best accuracy you will get after stating that min sample split should be 3, and then your default n estimators are 100, but your model is saying that you will increase your accuracy only when you use 150 decision trees in your random forest. So now we will again build our model, but now we are going to use this hyperparameteric values that our model has given us. We'll again say model is equal to random forest classifier. I will say n jobs is equal to 1, and then the random state is equal to 42. Now criterion, I'm not going to add the criterion explicitly because the default criterion is also the same. I will start with max features here. So max features 4, then max depth 7, then min sample split 3 and n estimators 150. So these are all the values of our hyperparameters, and now we will run this. Now we will say model.fit on xtrain and ytrain. Let's run that and let us check the accuracy now. So now we are getting an accuracy of 81%, which eventually increased. Initially you had an accuracy of 79%, but now you have increased your accuracy to 81%. Now as you can see in this particular model, the increase was just of 2%. From 79% it got increased up to 81%, but this was because we had very less number of rows into this particular data set, some 800 rows. But when you have large data sets like consisting of thousands of rows, like 50,000 rows, 70,000 rows, in that case this hyperparameter tuning will be very beneficial for your model. Now one thing you can say that here it showed that the accuracy is 83%, but after putting all this hyperparameters in your model and building your model upon that, you are getting an accuracy of 81%. There's a 2% gap here. This is because here you tried to check your model, you tried to evaluate your hyperparametric values on training set, but here we are evaluating our model on the testing set and not on the training set, and hence we are getting an accuracy of 81%. This is how basically you hyper tune your parameters in machine learning using the GridSearchCV technique. So that's it for this video. Thanks for watching.